probably already know this, but whales are incredibly noisy creatures, using tons of different clicks and squeaks for purposes that we believe are probably navigation and/or hunting. Much like myself, whales are also highly social communicators, so all these wacky noises are a vital part of keeping the pod together. And the males of just a few species, including humpbacks, even sing. But new research shows that these males actually learn these songs from each other and can pass them halfway across the globe. Ellen Garland is an expert on this, and she's joining me from Scotland. I remember learning as a kid that whales could sing, and I always thought that it was super cool, but reading even more about your research specifically is absolutely fascinating. It kind of puts whale song in a cultural context, right? So can you tell me a bit about that?
So we're trying to understand how and why humpbacks are actually singing, and then how they're learning these different songs and how they're passing them across this really vast region.
So just for clarity, can you explain what you mean by passing it through different regions?
So each population sings their own song each year, but the song is constantly evolving, it's constantly changing, and all the males in the population will accumulate, they'll learn those changes, and the song moves forward in small to large steps. But what we found in the South Pacific is those songs, those whole song types, are then passed to the next neighbouring population, and they learn it really rapidly and really quickly, and then it's passed to the next one and the next one. So we have this whole large chain of populations where songs are passed from populations in the west to populations in the east, and it's their entire song display. So they'll be singing this song, it's great, and then a brand new one will come in with a completely different arrangement, and they'll abandon that current display for this brand new display really rapidly, and it's an insane cultural change.
I almost want to compare this with our own human fashion trends, you know? In the 90s, everyone's wearing one thing, the 2000s come along, and we adopt a whole new style, and like with whales, it's kind of our way of finding a mate too, right? Having good sense of style?
It's a great analogy. A really cool new outfit comes in and everyone wants to wear it and wants to be seen in it, and then another one comes in, and it's just these waves of these cultural changes. The humpback song has all the hallmarks of a sexually selected signal, so whether they're displaying to a mate, whether it's to do with male-male competition, or both in a multi-message signal framework. So if you're singing something new, these new songs just jump out, they really stand out. So you would assume that a female, they're going to definitely hear these differences, and what that conveys to a potential mate, well, you know, that's a massive question.
Now, I understand that the term culture can mean a couple different things, so can you explain what you mean when you say culture in this context?
I define culture in a really broad sense as the shared behaviour or information within a community which is acquired through some form of social learning from your conspecifics.
So what we're talking about here is whales learning new songs, potentially from parents or peers.
Absolutely. So parents to offspring is actually vertical cultural transmission, and peers is horizontal transmission. We don't know exactly, of course, the function of the songs and what content is in there. And obviously this is a population identifier, so there's information on that. It's information that it's a mature male, and obviously he would be ready to mate. So there's that sort of is the information thus far I think we can safely talk about as part of the song.
Now, I understand you have some new research coming out. That is very exciting. So can you tell us a bit about that?
During my PhD, we traced the cultural transmissions of these song types across the South Pacific. So songs started on the east coast of Australia and were passed in a sequential pattern across to French Polynesia, which is in the central South Pacific. And we looked over a decade, and there was this unidirectional pattern. It always went east. And we know from previous research and other researchers that songs are passed from the west coast of Australia to the east coast of Australia. So we have this huge transmission network from the west coast of Australia across to the central South Pacific. And the next piece of that puzzle is to look from the central South Pacific to the west coast of South America. And so we have traced the song types spreading from French Polynesia in to the west coast of South America into the Ecuadorian population. So now we have song types that will spread across the entire South Pacific and almost around half the globe. It's in a phenomenal cultural connectivity network we've got going here.
To hear that humpback songs are learned and then passed right across the Pacific is just fascinating. What's the next thing you're hoping to find out?
To learn a new song type, you've got to be in acoustic contact. You've got to be able to hear each other. And we think with humpback song, it only transmits tens of kilometers in the water. So it's not going the full ocean basin. So there's obviously some connections, perhaps on the Antarctic Peninsula, but trying to understand how these populations across this vast region are actually interacting. Just because they're sharing song doesn't mean they're potentially breeding, or are they? So it's a lot of interesting sort of population understandings going on there. But also, does the song continue? Do we have this huge full circumpolar transmission around that southern hemisphere?
So what I'm also wondering is, can this research be used to help us protect whales?
In the South Pacific, we still have what are classified as endangered populations. So understanding the connectivity between these endangered populations is really important. Song seems to be a really sensitive indicator of these connection events, of these movements and potential meetings between the whales. So it's may help feed into some of these conservation measures.
We just touched on how Ellen's research can help protect whales, and now I'm off to meet Sophie Van Paris, whose team is trying to do exactly that, by listening for whales just along the coast.
Hi, Sophie.
Hi.
It is so wonderful to meet you.
Wonderful to meet you too. Come on in.
Thank you so much.
So I'm Sophie Van Paris. I run the Passive Acoustics Research Program here at the Northeast Fisheries Science Center. Right now, you're in one of our acoustics labs with all the equipment that we use to do our research.
I've been hearing a bit about how complex whale cultures can be and how vocal they can be as well, but I understand that you're listening to whales for a totally different reason, right?
Ship strikes are lethal to whales, can often be lethal to whales, and they're one of the two main sources of whale deaths. The other one is entanglement and fishing gear. And so ship strike is a real major concern, especially for the North Atlantic right whale. That's a critically endangered species.
Absolutely.
Yeah.
So you have a whole network of hydrophones along the Atlantic coast of the US listening for whales and ships and all of these other noises. So do you have one that we can take a look at?
Absolutely, for sure. So there's two different types of recordings that we make.
Right.
We call them archival. When we throw something like this out into the bottom of the ocean, we anchor it down with a weight. And when we want to go back and release them, we send a signal to them underwater. And so this will pop up, and our acoustic recorder, which has been down in the ocean for about 5 months, and this is the hydrophone here, recording everything it hears, will come to the surface.
So what exactly are the kinds of things you're picking up using these hydrophones?
Everything. So we listen to what we call soundscapes. Any whales that are making sounds, any seals that are making sounds, any fish that are making sounds, shrimp even make sounds. You can hear boats, you can hear underwater explosions or seismic activity, and you can hear rain, hear underwater earthquakes. So we listen to everything and anything that happens underwater. So we'll have some in the Gulf of Maine listening for right whales because they're endangered and there's a big problem there. We'll have them in wind energy areas prior to when there's going to be turbines that are being built. But in terms of ship strike, we tend to use recorders that are at the surface and not down at the bottom. So they're not archival, they're called real-time. So those real-time ones we tend to also put in areas where we know there's a lot of shipping. So it'll be in a shipping lane or in an area where there's going to be concentrated vessels active. So what happens is once you hear a sound, there's a little computer on board that actually is going through listening for different sounds of different whales, and once it hears them, it'll send that information up via satellite. It then goes to one of our research assistants in the group. She'll check it just to make sure the computer didn't make a mistake.
Yeah.
And then what we do is we send that information off to our regional office. So, and they will push that information out and put in place things that are called these dynamic management areas. They're really kind of these boxes that you draw around the sound that are put in place, and they warn mariners that whales are there, particularly North Atlantic right whales, and they need to slow down.
So if we get the ships to slow down, how much of a difference does that really make?
There's been a bunch of studies that have showed that slowing down, particularly to under 10 knots, whether it's a large ship or a small ship, can make a real difference in terms of the ability of the whale to survive a strike.
Okay, and so I would imagine that with very few, I think around 350 North Atlantic right whales left on Earth, that this is probably something that's really important to help protect them, right?
Absolutely. Anything we can do is going to be important to help protect them,
Yeah.
particularly with ship strike. If the boat's going too fast, it can be lethal. It can really injure the animal, and we really don't want that to happen. We have too few of these North Atlantic right whales out there.
Sophie, thank you so much for speaking with me today. Your work is absolutely inspiring.
There you have it. Whales learn songs just like we do, with people like Ellen tracking how the songs are changing and evolving. And that, in turn, helps people like Sophie find ways to better protect them and potentially save them from extinction.